Okay. So with paper 2, we have basically 4 topics that we're going to be looking at. Number 1, it is statistics and regression. Then we also have analytical geometry, we have trigonometry, and then lastly, we have the Euclidean geometry. So looking at the mark allocation of each of the topics, statistics and regression will go for plus minus 20 marks. Then analytical geometry, quite a lot of marks, plus minus 40. Then trigonometry will carry the most, which is a plus minus 50. And then lastly, the Euclidean will take on the 40 marks that will be remaining. So the total will be 150. And we need to be sure, and at this point, we need to be aware that the papers we're writing will be 150 marks, and we expect you guys to be done within 180 minutes. So roughly 1 minute for each mark. So a question like statistics should take around about 20 minutes or 25 minutes for it to be done. Now, I need us to go through the detailed scope of statistics. Okay, so when we look at, let's see. Looking at page 8, where are you? Page 8, page 8. There we go. So under statistics, they're telling us that candidates should be encouraged to use calculators so that they can calculate or determine the standard deviation. And then when they ask for variance, and then the equation of the least square regression. So in this case, when you need the standard deviation, you need to be aware of all the steps that must be followed of the mode, and then under the mode, which kind of data you're dealing with. Because remember, under statistics, we have what we call the univariate type of data, and then we have the bivariate. Okay, so under the univariate, we're talking about one variable type of data. An example, someone can talk about the marks that were obtained in a test, or the distance that was traveled in a marathon by different runners, and things to do with just one type of information. Okay, under this, the typical questions they ask for will be the mean, which is sometimes known as the average. Okay, then we also have the standard deviation. They can also ask for the variance, and then it is still under this that they talk about the box and whisker. Okay, so still under the univariate, remember the categories should be 2, the grouped as well as the ungrouped. Okay, so with this mean, standard deviation, and variance, it goes for ungrouped. When it comes to the grouped, which grouped deals with the intervals or classes. Okay, that's where we have the frequencies, the cumulative frequencies, and also the ogives, or the cumulative frequency graph. Okay, so we need to know how to work around this. So remember also that the mean or the average of grouped data will be just known as x bar, which you can get from the calculator. And then the mean, that is for the ungrouped. For the grouped, the x bar is the summation of f of x over the summation of f. When you get it to the interval table, where the x represents the midpoint, and then that is the total frequency. Okay, so they're telling us we need to know how to get that. Use the calculator to determine your A, your B, and then your R values. That is when you're dealing with the regression line. Okay, so regression falls under what we call the bivariate, 2 variables. In other words, we look at the x, and then we also look at the y. Just punch those values into the calculator and then get what is expected. Then the interpretation of standard deviation, okay, is not going to be examined. Okay, when they tell you about how big or how small the standard deviation is and all of that, it's not going to count. Then candidates are expected to identify outliers, okay, using our common sense in both the scatter plot as well as the box and whisker. Remember, initially, we are meant to use this kind of formula, where we look at the 1,5 and the Q1, so minus 1,5 times the IQR. Okay, that is when you're looking for the lower or the lowest number within the data set that seems to be an outlier. And then for the upper one, use the Q3 plus 1,5 times IQR. Okay, so in this case, they're not going to penalize whether you use this or not. Okay, but when you look at the data values, you should be able to tell which one is an outlier, either by looking at something that is too big within the data piece or that is too small. All right, so let's look at just sample questions and see. Okay, look at this question 1 that is talking about the distance that was traveled in kilometers by a group of how many learners? 9 learners. So this kind of question is a univariate, okay, because it's just talking about one type of which is just the kilometers. There's nothing to do with relationship or that. So the mean, which is the x bar, they use the calculator and get that. It's just a 1 mark question. Then the median, remember median is the middle number, okay? So this middle number can be obtained after data is arranged in order, which is already done. Remember, since it is 9 learners, so the middle number will be the median. If it's 2 numbers in the middle, get the average of those 2 numbers. Then they want the interquartile range, so you need the Q3 as well as the Q1, and then get the difference between those values. Then the box and whisker, remember it's a summary of 5 numbers, which is the minimum, the maximum, the Q1, the Q2, which is the median, and then the Q3, okay? So you need to know how to represent this. Usually there has to be a ruler or some sort of a scale that is drawn for you, and then you need to tell. Then identify an outlier. So from this question, when you look at outliers, 194, there's just a range of 6, okay? When I look at 24 and 34, there's a range of 10, or there's a difference of 10. So we're seeing that there's a bigger difference with the 24. So this 24 becomes our outlier. So just use common knowledge just to identify those outliers. So that is question number 1, which is statistics always. Then question number 2, which is also statistics. This deals with what we call the bivariant, okay? The 2 variables. So table shows the number of hours spent by learners, and then the marks, how much hours you spend in the preparation. So in other words, with this kind of data, they're looking for relationship between the data, okay? Is the data related? So that's what we call correlation, okay? So remember, under the correlation, we have different types of correlation, okay? 1, we have the positive correlation, and then we also have the negative correlation. And then under this, we also need to deal with the strength, okay? If the relationship is strong enough, under what values of R, because R represents the value of correlation, or the correlation coefficient. So in this case, they want you to represent the data on a scatter plot. So when you're drawing your scatter plot, just plot, I think they'll give you the diagram page where everything will be labeled, and all you do is the plotting. So hours represent the X values, and then the marks will represent the Y values for starters. Then when you're plotting, or when you're done with the plotting, do not connect the points. Just leave the points the way they are, maybe just as dots, okay? Something like that. That's what we call a scatter plot. Then when you're drawing, not drawing, they want you to find the equation of the line of best fit, or sometimes we call it the regression line. Okay, so with the regression line, remember the values of A and then the values of B. We need to find this. Y is equal to A plus BX. So use your calculator. Under the mod, you look for the AX. Is it the A plus BX? Okay, A plus BX. And then you proceed, enter the values for X and Y, and then you're good to go. And then hence draw the line of best fit. So when you're drawing the line of best fit, you can draw it using the equation that you obtained, or we can just estimate it. But with our estimation, if it is still on the same page that they're talking about, you need to get the mean value of the X's and then the mean of the marks. Okay, so your point or your line must rotate around this point that is having the averages. So the morale or the idea is just for us to have a line at the point of the X bar and the Y bar where we have close to the same number of points above and below the line. Then when you're determining the correlation coefficient, still we use the calculator. Use your calculator to determine the correlation coefficient. So that R value, remember, it's between -1 and +1. Okay, so if it's between 0 and 1, the correlation is positive. And then if it's between 0 and -1, the relationship is negative. Okay. Now that is just, first of all, determine the R with its number, and then comment on the strength, and then comment on the relationship. Okay. So the R value, let's say it's 0, probably 85, just taking an example. Okay. So that strength will be a strong relationship, but then the relationship is going to be positive. Okay, so you can tell us a strong positive relationship, or a strong positive correlation. So that way you get all the 3 marks. Probably 1 mark for the R, 1 mark for the strength, and then 1 mark for the direction. So that is what is expected with the statistics. So please and please, we need to familiarize ourselves. Okay, and as much as we can have this for question 1, it's still possible for us to have the cumulative graphs. Okay, and in those cumulatives, they can ask for the median, for the Q3s, and all of that. Okay, just the way these were asked. And sometimes they can even ask you to draw a box and whisker. Yes, it's possible. So let's familiarize ourselves with this content under statistics. So these are marks that we should not let go. All right, so we move on to the next topic, which is meant to be analytical geometry. Okay, so under analytical, what are the expectations? We need to prove properties of polygons by using analytical methods. What does this mean? It can ask you to prove where the shape is a parallelogram. So you need to know the properties of parallelogram. It asks you to prove that maybe the lines are perpendicular. Okay, and then they can ask you to prove is what we call collinear points. I think we shall look at that later on. Okay, collinear points. These are basically points that lie on the same straight line, and ask you to prove whether lines are parallel. So remember, with perpendicular lines, gradient of the first line, gradient of the second line must give you a -1. And then if the lines are parallel, we know that the gradient of the first line must be equal to the gradient of the second line. Okay, you can use the distance formulas, the midpoint methods, and all of that. We need to know that. Then the concept of collinearity must be understood. That's what I was discussing, the collinear points. Okay, so collinear points are basically points that lie on the same straight line. Okay, if we have a point A, we have a point B, and probably a point C. If these points are collinear, then we expect the gradient between the points to be the same. An example, we know that the gradient of a straight line is always constant across. So in other words, if we are to use the points, we need to apply the knowledge of the gradients. So what we can do and say is that, let's say the gradient of AB, or the gradient between AB, should be the same as the gradient between BC, which is also the same as the gradient between AC. Okay, we use any two. Questions can be asked whereby maybe there is a missing coordinate, and then we just have to use the same thing. So remember also the formula for determining the gradient is the change in y over the change in x. Okay, not the other way around. Candidates are expected to be able to integrate the Euclidean geometry axioms as well as the theorems into analytical. So there are cases, let's say when you're talking about mostly circles, okay, and then they bring in issues to do with tangents. Circles and tangents, that is knowledge from Euclidean geometry. Apply the same properties. At times you can be given the two tangents and you know that tangents from a common point will be equal, or you can be given things that deal with the tan chord theorem. We should remember that. Then the length of a tangent from a point outside of a circle should also be calculated. Okay, then concepts that deal with concurrency will not be examined. So that is fine. Let's look at the sample questions under analytical. You said it's carrying quite lots of marks, okay? When you look at question 3, they are telling us that in this figure, we have the coordinates of K, which is X, Y, L is that, and then M is that. These are vertices of a triangle. And then they gave us the equation of KL, then they also gave us the equation of KM. And then they are telling us that N is a midpoint. So this word midpoint is going to play a big role, okay? It deserves to be highlighted. So all the information that we have within the statements is recorded within the diagram. In cases where information that you're given is not on the diagram, please, you need to indicate it as well. Then they ask you for the coordinates of the midpoint. So remember the midpoint formula, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2, regardless of how you write it, okay? Some people say y plus y1 or whichever format, guys. Ne? Then they ask you to show that k is -1 and 4. This is k, a point where two lines are meeting. Remember, they gave us the equation of KL, and they also gave us the equation of KM. So at a point where two lines are meeting, we're saying that those lines will be equal to each other. So get the equation of KM and equate it to the equation of KL. In other words, solve these equations simultaneously. Okay, you can make y the subject in both equations, or you can make y the subject in the first equation. Let's say y is equal to 5x plus 9. Get this y, and then replace it there. You solve for x. And then that x, get it, substitute it in either equations, and get the values of y. So when lines are meeting, the lines are equal. Then the equation of a line that is passing through Q and N. So you know the coordinates of N, we know the coordinates of K. You just need to get the gradient, which is the M, and then get the y-intercept. Then you're good to go. Then gradient of the line, LM. Use the gradient formula, okay? And hence, so this word hence is like from where you stopped. So after getting this gradient, can we use that gradient to prove that Kn is perpendicular? Remember what we said? Get the gradient of LM, you multiply it by the gradient of Kn. If you get a -1, then draw a conclusion. 3.5, they are telling us we have this point J that is on the same line as LM, and they are telling us that those points are collinear. Calculate A, use the gradient. Okay, then the size of the angle of inclination. So when we have angles of inclination, we have M is equal to the tan of theta. Okay, if theta is our angle of inclination between the x-axis and that line. Okay, we normally prefer using the positive x-axis. Okay, so this angle is what they want. So remember, for you to get that angle, you need to know the gradient. Okay, so we can say theta will be the arctan of the gradient of that line. Now, if it so happens that you get a negative value, okay, it's a -120, just plus 180, so that you end up with a positive answer. So regardless of which value you get, but as long as it's a negative, you need to always give us a positive answer. Then if the answer is positive, well and good. Now, there are cases or there are scenarios whereby we apply Euclidean geometry, where let's say a triangle is drawn, but the lines are not reaching. Yes, you're allowed to extend that line. Okay, let's say if they wanted the angle of inclination of Km, extend the line till it meets the x-axis. Use the gradient and then find that angle. Or sometimes you can be given this as a theta, then this as a beta, and then maybe this is alpha. And then they ask for the missing kind of angle. Okay, so just know how to work around with that. That's what they said about the Euclidean properties. Okay, so always we know that this angle will be the same as this angle. Okay, and then this angle and this angle will be that, exterior angles and all of that, guys. Ne? We need to remember that. Question number 4 that deals with the circles. So with the circles, we need to know the general equation of a circle. It's x squared plus y squared is equal to r squared. That's if the circle is passing through the origin. If it's passing through points other than the origin, then x minus a squared plus y minus b squared is equal to r squared, where a and b represents the coordinates of the center. That we need to remember. And then at times you can be given a generalized equation, and then they ask you to transform it back into this. So that's where we apply the completing of squares. Okay, we need to complete the squares and get that right. So here's an example where the circle was drawn for us and it's passing through the origin, and we have points that are missing, and then they're telling us that there's a tangent. Okay, so when there's a tangent, chances are high we're going to apply the Euclidean concepts. Then they want the equation of the circle. So since the circle is passing through the origin, all we need is just the radius. We have the origin, which is 0 for x and then 0 for y. Use OQ and then get the distance formula. That will be our radius. And then substitute it there. Then the length TQ, this length. So we know that OQ is a radius, but then even OT is also a radius of the same circle. So which means the distance that we got here must be the same distance that you have there. If let's say it's a 5, then these coordinates are going to be 5, 0. Then after getting the 5, 0, then get that distance using the distance formula. Then the equation of OQ equation. So that is a straight line, mx plus c. Okay, the c, we already have it as the y-intercept, which is a 0. So focus on just the gradient. Then the equation, they want the coordinates of P. When you look at P is a point that is meeting the circle. Now we got the equation of OQ, which OQ is the same as the PQ. It's the same line. For us to get the coordinates here, remember, P is meeting the circle, so get the equation of that line and then solve it simultaneously with the equation of the circle. Okay, let's say y is equal to, let's say, -4/3. I'm just saying, if that is our equation. So this equation will be solved simultaneously with the equation of the circle. Where there is y, replace this, and then solve for x. So you'll get two values, so it will form some sort of a quadratic. One of the values will be x, and then the other value will be a negative value somewhere there. Get that negative value, you can even substitute it into the equation of the line or the equation of the circle, and then get the y value. Equation of QR, okay, remember QR is a tangent, né? And for tangents and lines from the center, they will be perpendicular. Tan diameter, tangent and the diameter will be perpendicular. So since you have the equation of this, or you have the gradient of this, you can find the gradient of that and get that. So that equation will also be used to help you find K. All right, so that is to do with analytical geometry. But before I leave it, there is this question that talks about two circles, okay? So let's say we have two circles. This circle with center A, and then we have another circle that is B. Question can come and ask you to prove whether these circles are touching at one point, at 2 points, or they are not touching at all. Let me have another scenario here where the circles are touching at 1 point, and then a last scenario where the circles are now touching at 2 points. Okay, so with this, let's say the first one. We need to get the distance AB. Now, if our AB is greater, okay, than the radius of A plus the radius of B combined, then the circles are not touching. They are far apart. Then, if the distance AB, using the distance formula, and we're going to have the coordinates of A and then the coordinates of B. So using those coordinates, the distance formula, if the AB is equal to the radius of A plus the radius of B combined, then the circles will be touching at 1 point. Otherwise, they will be tangents to each other. Then with the last scenario, if our AB is smaller than the radii is combined, then the circles will be touching at 2 points. We just need to remember this. So remember, we said analytical geometry can be applied. So don't be surprised if maybe they bring also cyclic quadrilaterals involved, tangents from a common point, just as we stated, our highlighted area alone. So just have hope and faith. We can do this. Let's move on to the next topic, which is the trigonometry. Trigonometry. Okay, so under trig, no one is going to ask you about the ratios of the cosec, sec, and cot. But if you use them to get the answers right, we have no problem, okay? But no one is going to ask you, find the cot of this, find the cosec of that. No, not in metric for now. Then the focus of the trig graphs is on the relationships, simplification, and determining the points of intersection, okay? We need to know how the graphs look like. An example And you talk of the sine graph, the cosine, and all of that, and then their intersection. So before we really go deep with this trig, just need to remember one thing, that trig is broken down into parts. Okay, the first part is the one that tests on the ratios. Okay, with those ratios, we normally use this SOCAT or something. I don't know how people remember this, but that's what I use. So you need to remember the trig ratios, and remember these trig ratios only work with right-angled triangles. Okay, then besides the ratios, or just as part of the extension of the ratios, this is where we find the proofs. We also find the reductions under this. Okay, now a kind of separation from the right angle triangles, but the proofs, the reductions, the general solutions. Okay, in as much as general solutions can also be brought down into the functions. Then we also have, what else? I think that's fine with the ratios. Then we also have the functions, which is the graphs. So under this, at least know how to sketch a sine graph, a cos graph, and then a tan graph. Just the basic one, okay? As much as they can once in a while ask you to sketch a graph and then answer questions that follow. At least just familiarize yourself on how you use a calculator just to plot a graph. Besides that, how you determine the general solution also from the graphs, okay? And then how you determine, let's say, the periods, talking about period. And then we talk about the amplitude, not so common, but it's possible. Amplitude, and even the range, how it is stated and written. We need to know that. And then besides the function, we also have what we call the rules. In other words, the trig rules. We need to know them. So we have three. We have the sine rule, we have the cosine rule, and then we have the area rule under 3D and 2D trig. We just need to remember that. So basically, that is the trig broken down. Carries the most marks, remember, né? So let's see, as we break down this further, they are telling us that if we have a question like this, which in most cases doesn't miss, né? They give you the tan alpha is equal to this, and then they give you the range of degrees where we must find this. Then they are telling you to use a sketch to determine the value of the function. So there are scenarios where we use the sketch. Number one, this is scenario number one. And then the other scenario is where they give you, let's say, probably the tan of 25 is equal to m. And then they ask you to give the following in terms of m. Okay, so even this kind of scenario, you'll need a sketch. But the sketch of this one is just any type of sketch. And yet with the sketch of this one, you need to pay critical attention on how you draw the sketch and in which quadrants. Okay, so looking at 5.1, you need to know your Cartesian plane. Okay, so 0, 90, 180, 270, and 360. So we label angles, or we measure angles in the anti-clockwise direction. So they told us between 0 and 180, so we're looking at quadrant 1 and quadrant 2. From your cast diagram is something like this. Now we look at your tan. This tan is negative. So between quadrant 1 and quadrant 2, where do we find tan to be negative? It's basically quadrant number 2. Okay, so if it's quadrant number 2, then draw your right angled triangle, which must make a 90 with the x-axis, not the y, with the x-axis. Then substitute these values or label your triangle. So we know that from the SOCAT that we saw. Okay, the tan is opposite and adjacent. So the opposite is this 5, the adjacent is this 12. Now, when you look at the 5 and the 12, which one is on the negative arm of the axis? It's the 12. Okay, then you need to complete this triangle using your Pythagoras. So if the triangle is complete, let's say I have this as a 13, then I can use this triangle to go and simplify this. Remember, the instructions are clear without using a calculator. So please do not find the value of alpha and then use that here. That would be wrong. It has to be from the triangle, and then we have those ratios written down. So we have no problem if someone decides to use the calculator and just simplifying the ratios. For as long as your final answer is just a common fraction, we shall be happy with you. Okay, then 5.2, they're telling us to simplify the expression to, they highlighted these capital letters. In English, it would be wrong to write capital letters in between, but in maths, it's allowed. So expression to 1 trig ratio of P. So these are reductions. Reductions still take you back to the Cartesian. Remember, 0, 90, 180, 270, and then the 360. This quadrant is known as the quadrant of 360 plus, and it's also known as the 90 minus. This is a quadrant of 90 plus, and it's also known as a quadrant of 180 minus. The quadrant here is 180 plus, and then the last quadrant is known as a 360 minus. So having highlighted those angles, remember which ratios are positive. So all ratios, sine, the tan, and just the cos. So this needs to be applied concurrently. Okay, so when you look at the first one, sine 360 minus, that is quadrant number 4. And in quadrant number 4, the sign is negative. So that's kind of a negative sine P. When you look at the cos of 270, you can just use a calculator, put it inside the calculator, or punch it inside the calculator, you'll get a 0. Then over sine of 90. Now with the 90 minus and the 90 plus, these are complementary ratios. An example, if you have the sine of 90 minus or 90 plus, this is going to give us a cos. If it's a cos, then it must give us a sine. Okay, so I'm going to call that cos of P, positive. And then the tan of 180 plus 180 is in quadrant number 3, and in this quadrant, tan is positive. So you'll have something like a tan P. And then 360 minus for tan, it's negative. Okay, so the tans cancel, and then you simplify. You're good to go. Then 5.3, calculate the values of x. Okay, you have sine x is equal to cos 2x minus 1. So this is more like a general solution, but we shall need definite values of x. Okay, so when you're solving general solutions, the idea is, one, to either create the same kind of ratio. An example, just focus on maybe sine across, and then you work that out. Or if you can't have that possible, you could apply the factorization if and whenever it's possible. So in this case, we have the double angles. So double angles, of course, use the one that has the sine squared, so that you have just the quadratic and then solve that quadratic. Remember, as you're solving this, that last part of the k times 360, that is going to be relevant after getting your reference angles. And then you just need to replace the k values with integers, positive 1, negative 1, and so on and so forth, with a 0 up until you get answers between negative 90 and 270, and just choose or take the values that are within just the range. Okay, question number 6, they're telling us to sketch. Is there any other nuggets we need to give for this? Probably, yes, before we leave it. Before we leave this, we need to remember the identities. Okay, let me just take this out. So we're saying, number 1, just know this formula, the SOHCAHTOA formula, how to apply the ratios. Then also remember the identities. Okay, we have quite a number. Number 1, we have the sine squared plus the cos squared must give you 1. So some of these are just on the formula page. You can just get them. Then we also have sine x over cos x. This must give us the tan of x. That's also another identity we need to remember. Then we can have the double angle identities. sine 2x, which is 2 sine x cos x. We need to remember that. And then the double angle of cos has 3 parts. You just need to get those 3 parts right from the formula page and apply whichever one is applicable at any one point, okay, depending on the scenario. Then besides these double angle identities, we also have what we call the compound angles. We need to remember them as well, interchangeably, okay. We'll just take this away, just focus on this. So the cos, okay, we have the sine of, let's say, alpha plus minus beta. You know how to expand this. And then the cos of alpha plus minus beta, you should also know how to expand this. Sometimes they can give you the expansion and they expect you to move backwards. So you need to be alert and see what is going on. Okay, I'll look at question 6, which is to do with the functions. Remember, with the functions, you need to know what the domain is. That is the x values. Okay, and in this case, we're going to be talking about degrees. Okay, and then the range, those are y values. Okay, under the y values, we look at the maximum as well as the minimum. So it's only the sine and the cosine that will have definite values of the maximum and minimum. Okay, with the tan, the range is infinity. Okay, positive and negative infinity. Then we also need to know about the period of these graphs. So we know that sine, the sine graph, and the cos graph both have a period of 360. The tan graph has a period of 180. You just need to bear that in mind. That is if it's a basic trig graph. Now, if now there is an introduction of maybe a 2 or a 3 or something, that number does affect the period. So just divide the original period by that number 2 or 3 or whatever, and then get the exact period of that particular graph. Then at times we also talk about the shifts. Ne? Let's say we have sine of 2x plus a 1. This one represents a vertical shift along the y-axis, so which is upwards. So which means this graph was moved 1 unit up. If it is a sine, let's say 2x plus 20, at times we put that in brackets. This 20 degree or the 30 degree represents a shift within the horizontal axis. So if it's a plus, which means the graph was moved to the left. If it's a minus, let's say 2x minus 30, the graph was moved to the right. You just need to pay attention to those signs. Okay. Then remember we said sketching, at least know how to sketch, and then answer what comes after. So in this case, we have f of x as that, and then the g of x is that. It's a line segment at point C and stuff like that, and then d is that, blah, 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 blah. Now, they want us to get the length of AB. So this is A, and then that is B. But we know that both A, B have the same common point, which is negative 135. So it's up to you. You can choose to substitute the negative 135 into these equations, F and G, and then subtract the values. Okay, you get those 3 marks. I think that's way better. So since the graph of F is on top, you can say the graph of F, let's say f of x minus the g of x, and then just substitute negative 135. Then they want the period of f. Remember, with period for a sine is 360, but since we have a 2, that 2 is going to reduce the sine graph to the period to 180. Okay, you can see that even from negative 180 up to positive 180, we have just one graph. Okay, then use the graph without calculations to determine intervals where f of x is greater or equal to g of x. So when they ask you for this, number 1, f of x being greater, f of x has to be on top. So where do we find the graph of f to be above? So it's between negative 180 and then this point D. So what we need to do, we need to determine the values of D, or the coordinates of D. Same story when you look at the negative 90 and this point here, we can see that the graph of f is still above, because after that, the graph of f goes below. So we don't account for this. It's just the two areas, just this before the negative 90 and then after the negative 90 within D up to the negative 180. So we say we're focusing on this area, okay, and then we're focusing on this area. So get the values of D. Those values of D will be more or less the same as this point here. Play around with that, get those values. Then one other thing that they always ask is f of x times the g of x being greater equal to 0 or less or equal to 0. Just need to know how this works. Then at times, if they don't do this, they can just say f prime of x times g of x. So f prime of x is the first derivative of x, which focuses mainly on the gradient. So you need to know when is the graph's gradient positive, when is the graph decreasing, and when is it stationary. Pay attention to that. Okay, so that is what happens under the trig functions. Someone is saying amplitude. So with the amplitude, it's not a big deal. Usually it's, maybe let's use the general format of getting the amplitude. You get the maximum minus the minimum divided by 2. Just that. Question number 7. Question number 7. Question number 7. Which is also trig, but this is the 2D trig. Yeah? They want you to redraw the sketch and then prove. So when they ask you to redraw, normally questions that have to do with proofs, they will have constructions involved. Please do the constructions. Okay, create a height in this case. So this will form part of the rules. Remember, we said we have the sine rule, which is usually given. A over sine of A is equal to B over sine of B is equal to C, formula page. We have the cosine rule, which is maybe C squared is equal to A squared plus B squared minus 2AB, the cos of C, the angle. Then we have the area rule, which is, let's say, half A times B, the sine of C, or A times C, the sine of B. Just remember that, because area rule is not on the formula page, but sine and cosine always there. Okay, so in this case, if we have this, just know how to label this triangle. So that is a C, since it is opposite, because remember this angle will be determined by how long this line is. This is A, and then this is our B. Okay, create perpendicular height. When we have perpendicular heights, then the trig ratios can come back. Okay, we can say the sine of B, which is the opposite, which is H over A. Make H the subject. You have A sine of B. Then if you have, let's say, the sine of this angle A focusing on this triangle, okay, sine of A, the opposite is H over B, make H the subject, it's the B sine of A. Equation 2, probably equation 1, and then equate the two equations, and then divide through by sine A sine B, you'll get to that part. Then question number 7.2. So in normal cases, if they ask you to prove about the sine rule, then whatever comes after is just an application of the sine rule. Okay, from A, they're telling us the angle of elevation to the tower is x squared. That is the distance, elevation is that. So angles of elevation and depression just carry more or less the same meaning, as long as you know how to work with them. Okay, so if that is, let's say, another horizontal surface that is parallel to what we had originally. One thing you need to know is that if this is x, even this angle here is going to be x. And then if this is a y, which means even the angle somewhere here is going to be a y. What does that make this angle inside here? It's going to be a y minus x. We just need to remember that. Because I'm seeing with the proof that we are having, we have y minus x, which means this y minus x is going to go with this d, if I'm focusing on just this triangle here. And then this x can basically go with db. So which means you have to start with the first angle CBD and get the side BD, okay, which is going to be what is it going to be? Remember, sine of y is equal to the opposite over the BD, which is going to be h over sine of y. And then use your sine rule to work on that triangle. You should be able to get to that. Then 7.2.2, if let's say you're given the height, or they calculate the height if you're given these variables. So even if you fail to get the first part, please just get these numbers of these values, substitute them there, get those marks, okay? Then 8.2, trig never disappoints, né? There we go, compound angles. That and that, we need to prove that it is that. So just open those brackets using the compound formulas from the formula page. If you have a sine of x plus y and the sine of x minus y, how do we open that up? Collect the like terms, then you're good to go. Then hence or otherwise, so it's either you use what you obtained up there to just draw the conclusion this side and do the proof, okay? So under this, remember we said we have identities, those identities that we need to remember. And then we have two sides. We must prove that one side is equal to the other. Guys, start with one side that has the most number of terms. So in this case, the left-hand side would be the best, okay? With the left-hand side, we're seeing a 3x. Expand that 3x, okay? This 3x can be written as x and then the 2x. Try to expand the double angle of this, sorry, the compound angle of that. And then this is a cos 2x. Find the compound, the double angle of the cos 2x. But since our right-hand side is having just a sine, just change this cos into the double angle that has a sine. Factorization might be involved, and then solve that. So guys, that's the trig. Okay, 40 is it 40, 50 marks, the most. So just know your things, just know your story, and come prepared. It's a topic that is passable if we can get at least a good 3/4 of those marks. It will be good, well and good, okay? Then even the total, it's fine. We can allow even the total. We won't be stingy to give you the total. Then the next topic is basically the Euclidean geometry. Euclidean, okay? They're telling you that Euclidean and measurements. So these measurements are usually under, what we call it, the proportions sometimes. Yeah, but the calculus that was done in paper 1 has those measurements mainly, okay? So they're telling us that measurements tested in calculus, okay, we saw that, the 2D, so when you have the 2D dimension trig, okay, or the 3D, it can also account for the measurements. Okay, composite shapes, these are basically two shapes that are combined together. They're telling us we only have maximum of 2 shapes, we cannot have 3. We can have a cube and maybe a rectangular prism combined, or okay. So under Euclidean, we need to know the following proofs. Please and please and please, the first theorem, theorem number 1. Line drawn from the center of the circle perpendicular to the chord. We need to know how to prove this. Okay, we need the proof. At least come to the paper knowing some steps. Remember, constructions are involved. Because with this first theorem, remember, we also have right-angled triangles, which means we can have the Pythagoras. Okay, and then congruency. Okay, congruent triangles and things like that. That is the first proof. Then the second one, line drawn from the center of the circle and bisects the chord, will be perpendicular. This is just related to the first theorem. Okay. Then the line subtended by an arc at the center of the circle is double. Angle at the center is twice angle at the circumference. We also need the proof of this one. It's very much loved. Ne? That proof, we need it. And then the opposite angles of a cyclic chord being supplementary, this proof. Okay, and then the last proof is the angle between the tangent, which we call the tan chord theorem. Just not list those 4 proofs, okay? Just for the first part of Euclidean. And then the last proof that is normally needed is the proportionality theorem, okay? Where you're given 2 triangles. Okay, you're told these lines are parallel, and then you have another triangle here, and you have to do some constructions and prove what is happening there. The other one under proportions is where you look at maybe this one triangle and you have to construct the perpendicular heights and things of the sort, and then you do the proofs as well. So just know these four and how to work with the proportionalities. Okay, so a line drawn from one side of a triangle divides the other two sides proportionally. So that's where we go. Then equiangular angles are similar, so this and this, those are the equiangular. So we need to know all of that. Then corollaries that are derived from the theorems and axioms that are necessary in solving radii. So number one, angles in a semicircle, remember, it will be a 90. So it's like you have a circle and there has to be a diameter. Okay, so if this line is a diameter, then the angle by the corner has to be a 90. That's what they're talking about, angles in a semicircle. Then equal chords will subtend equal angles at the circumference, we know that. Then equal chords subtend equal angles at the center. Then equal circles, equal chords subtend all of that. Okay. Then we have the exterior angle of a cyclic chord. Now remember, for a cyclic chord to have an exterior angle, let me have this. There has to be an extension of one side. There has to be an extension. Okay, so we're saying this angle here must be the same as that angle. Then we need to know that then the opposite angles, we say they are supplementary, so that the exterior angle of a cyclic chord is equal to the interior opposite. That's what we said. But this can come under the proofs, where they ask you to prove that the shape is a cyclic quadrilateral. Remember, we have 3 ways of doing this. Number one, you can use the exterior property. You can use the opposite angles being supplementary. And then we have this one also, the subtending part. If this angle is the same as that angle, then this whole shape is a cyclic quadrilateral. It doesn't necessarily have to be in a circle for it to be a cyclic quadrilateral, but for as long as it satisfies the properties of the proof. Okay, then they're telling us that if we have tangents from a common point, okay, outside the circle, those tangents are equal. So you have your circle, and then you have your lines that are moving from one point. So those ones must be equal in length. That we need to know. And then the concurrency is not part of our discussion today. All right, so before we go to the sample questions that we have, one thing we need to remember we said theorem 1 just works with congruency and Pythagoras. The second theorem, or the theorems of the center, normally focus on isosceles triangles. Okay, and those isosceles triangles work with the angles at the center. Is it not angles at the center? Angles opposite equal sides. We need to know that, at least isosceles triangle, most of the theorems of the center. And then we have the cyclic quadrilateral. Remember, we have 3 aspects: the exterior angle, the opposite angles, and then this other one for the proof mainly. And then we also have the tangents, the tan chord. Just need to know how it is structured and how it is. Okay, so that is all we need to know under this, and as well as the proportionalities. Okay, proportionalities, and then similar triangles. How do we prove similarity? Because that is also loved. Okay, so triangles will be similar if they have 3 angles that are equal to each other. In grade 12, we don't normally use the sides. Sides will be used after proving that the triangles are similar using the angles. Okay, so let's see. So in the first question, in this case is a question 9, we always have to give reasons for the statements that we write. Okay, so this is a topic that can be done within the shortest period of time. That is if you understand your story. Okay, but most learners run away from it. I don't know why. Guys, do not leave questions blank, at least attempt. Okay, so in this question 9.1, they're telling us O is the center and then OS is perpendicular. What are they saying? Prove. There has to be a proof question always, but from those four. Okay, from the first four, remember, line from the center, or angle at the center, or it could be the turn chord or the cyclic quadrilateral. One of those four, at least there has to be one that talks about the proofs. And then the questions that follow, we'll be talking about what we just proved. Someone will ask, how do we prove this? Please just go through your notes. Remember, constructions have to be done. You don't just start writing your information without doing the construction, because there has to be a frame of reference at any one point. 9.2, you have a line A, B, C, D with two concentric circles. So basically circles with the same center as shown. They give you that information that OA is 25. They're telling us OC is 17. Okay, if determine AC, the distance from here up to there. Now remember this theorem, we've said Pythagoras is the way. Okay, with all the triangles you look at, there has to be Pythagoras that will be involved. So apply the theorems, remember one triangle at a time. So you can look at the OXC, you get the distance, XC. Then you look at the OXA, you get the distance, and then add up the two. You have your 5 marks. But you have to give reasons, guys. You must give reasons. Then show that AB is the same as CD. Okay, so this might require some bit of extension. And how would that extension be? Let's say if we just extend O to D. Remember, OA is the radius, which is 25, which means even OD is also 25 because it's radii of the same circle. Then you have your triangle OXD. Okay, if this is a 15, is that what I said? OX is a 15. Okay, if that's a 15, then we can find the XD. Then do the same thing, find the distance AX. So we said XD, and then find AX. But we know that it's a line from the center, perpendicular to the chord, it must bisect, which means X is the same as that. Okay, so if that is that, just subtract that, then the answers you get will be the same as C and D. Question number 10, so please also the statements of the theorems, we need to be able to complete them. So in this case of the opposite angles of a cyclic quadrilateral, what are they? They are not equal, but they are supplementary. Okay, so if two angles or if two triangles are equiangular, then the corresponding sides will be what? Are they going to be equal or in proportion? I don't know. 10.2 are telling us that PQR is a tangent to the circle. Okay, there is a tangent. Pay attention to the word. Then we have parallel lines. That is also relevant. We have equal sides. And then Q3 is a 30, and then D3 is a 7. Guys, we don't just give information for fun. Whatever we say has some bit of relevance, okay? So the first point, they're telling us that calculate Q1. So this is the Q1. Q1 is the angle between the tangent and the chord. So we can use the tan chord, okay? Then prove that C is 110. This is our C. How many cyclic quadrilaterals do we see? We have like 2 cyclic quadrilaterals. Okay, so you can highlight this. People with highlighters, make good use of them. Okay, feel free to highlight. It's your paper. Highlight so that you can see nicely. So we had parallel lines. So if that's a 70, then that's also a 70. And then you focus on that opposite angles. You have your 110. Then B1, where is B1? This is B1. So B1 is opposite to this Q2 under a different cyclic quadrilateral. Okay, if I just highlight it, something like that. So which means I need to first of all get this Q2 if I look at the angles on a straight line. Okay, I'll have my Q2, then I can get the B1 opposite angles. Then 10.3, DO is a diameter, DF is this, and EE are Q codes. They're telling us GH is perpendicular. Okay, there's a 90 there. Can you prove that G1 is the same as E? So in this case, you need to prove similarity. Okay, so which triangles are you focusing on? We're looking at this small triangle and then the macro triangle. So you can start by telling us that F is a 90. Why? This is a diameter, so that's an angle in a semicircle. That is true. We have D that is being shared by the two triangles. So which means G1 will be the same as E, the remaining angles of a triangle. And that's what they wanted. So prove the similarity, you're good to go. Just know what to do, highlight if you can. Then question 11, in the diagram that is accompanying, okay, AD is 15 and they gave us that information. If those lines are parallel, can you calculate the length of AC? So proportionality theorem must be used. Okay, if possible, just get to know which triangles are similar to which one, and then you're good to go. Same story with 11.2. Okay, they gave us PAS is a 90. Okay, and they told us it's a rectangle. We need to know the properties of a rectangle in this case. Okay, so PAQ is what they need. Can you prove that PAQ is the same as A is R? Prove. Remember, with the rectangle, this side is equal to that side, and all of that side is equal. So use the information that is given to just prove that. Then can you prove that this triangle is similar to that? So look for the basics. Triangles that they're talking about is APQ. Okay, this triangle. And then which one? AR. Oh God. Okay, so this one. You just need to prove that those two triangles are similar. And then when you have values given and you have to calculate the unknowns, just use the proportionality theorem and compare the sides that are in proportion to the triangles that you identified. In most cases, it will be a question of proving similarity and then the application of the similarity based on the sides that will be in proportion. So guys, that is that. You just have to be confident. Okay, besides that, try to do questions that you're confident with first. Okay, in other words, start with questions that you're comfortable with so that you can save quite a lot of time. And then the other thing, try as much as you can to attempt most of the questions. Okay, I don't advocate for people skipping questions just because they don't know, they don't understand anything within the paper. Just try, write out something, okay? I believe there's something that you can write, at least for each and every question. Thank you very much, guys, and I wish you all the best, okay? I salute, I sign out.